Physics Part 109. The corresponding relation between pressure and temperature is for a given mass of gas maintained at constant volume, the pressure P of the gas is directly proportional to its thermodynamic temperature P. Well, this is Gay-Lussac law, or the law of pressures. The equation can also be written as P1 over T1 is equal to P2 over T2, where the subscripts 1 and 2 again refer to the initial and final values. We can combine the three gas laws into a single relation between pressure and pressure P, and volume V and temperature T for a fixed mass of gas. The relation is P1 into V1 over T1 is equal to P2 into V2 divided by T2. All the above laws relate to a fixed mass of gas. Another series of experiments could be carried out to find out how the volume of a gas held at constant pressure and temperature depends on the mass of gas present. It would be found that the volume is proportional to the mass. This would give the combined relation PV, where PV is equal to AMT, where A is constant of proportionality. However, this is not very useful way of expressing the relation, as constant A has different values for different gases. We need to find a way of including the quantity of gas. The way to do this is to express the fixed mass of gas in Boyle's, Charles, and Gay-Lussac's laws in terms of the number of moles or gas present. We have met the moles in our previous chapter as one of the base SI units. The mole, abbreviated as MOL, is amount of the substance which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon minus 12. The Avogadro constant Na is the number of atoms in 0.012 kilogram of the carbon 12. That is, it is the number of atoms in a mole of atoms. It has the value 6.02 into 10 power raised to 23 mole minus 1. The relative atomic mass of the ratio of the mass of an atom to 1/12 of the mass of an atom of carbon 12. Since the definitions of the mole and the Avogadro constant relate to 0.012 kilogram or 12 grams of carbon minus 12, the relative atomic mass is numerically equal to the mass in grams of a mole of atoms. Similarly, the relative molecule mass M1 is the ratio of the mass of a molecule to 1/12 of the mass of an atom, carbon minus 12, and is numerically equal to the mass in grams of a mole of molecules. The atomic mass unit U is 1/12 and the mass of an atom of carbon minus 12, and the value has the value of 1.66 into 10 power raised to minus 27 kilogram. This quantity is also called the unified atomic mass constant. Thus, a simpler way of finding the mass of one mole of a particular element to take its nucleon number expressed in grams. For example, the nucleon number of argon AR-40 is 40 on mole of argon then has a mass of 40 gram.